Hello guys and welcome. So today we'll break down yet another advanced SQL query step by step, focusing on few advanced window functions different from the ones in the previous video, so like lead, first value, last value, percent rank, and standard deviation. So we'll also explore how partition by structures group analysis, enabling comparisons and insight into trends and relationships. We'll also use break on to enhance report readability in the end. So let's get started. So as you can see here, these are the two tables that I'll be using to build my query. So it's the same ones that I've used in the last video. So to recap, scientists is my parent table, research project is my child table, and it contains information about scientific research project as well as the scientist information that's conducting the project. Now, let's get started here. So we'll start with an aggregated view of project metrics, so grouped by discipline, university, and nationality. So I'll build a query using several analytic functions, so like count, sum, minimum here. So basically it counts the total of scientists in each discipline per university, as well as the publications and the total project value as so. And this query basically provides a foundation by summarizing key metrics, like here basically I mentioned earlier, and it's really important because it lays out a foundation for us to build a query later on. And to move on, we'll be using partition by lead and with lead as well. So basically let's run that real quick. So to recap, partition by is basically a class that organizes data into smaller groups while keeping all rows intact, and it's different from group by because group by collapses rows into a single summary. So this is really good for basically performing row-based operations within defined subset, so like comparing current and future rows or calculating trends over time. So for instance here, partition by discipline creates separate groups for each discipline, and within this order by sequences rows, allowing us to analyze data changes within each group. So in the subsequent queries, you'll see how partition by here empowers window functions like lead and lag. So now let's move on to lead. So lead, basically we'll be using lead alongside partition by. So lead retrieves values from the next row within a partition. So it's ideal for identifying forward-looking trends. So you can see here, lead fetches the next row's total project value within each discipline, enabling comparisons across time. So it doesn't accumulate values, however, it only retrieves a future row's data for direct comparison. Similarly, lag is performed the same thing, but it retrieves value from the previous row, so it allows historical comparison. But with lag, you can access changes over time by comparing the current row's values to the previous one. So like lead, lag doesn't accumulate values, so it simply retrieves the previous row's value. And you can see there's blank spaces here. As the previous video, we talked about how lag works basically. So if there's a basically if the previous row is blank or null, it will show up as blank, or if it's in the first row, it doesn't have anything to compare it to, so it'll show up as blank. Same as lead, if it doesn't have anything to compare it to in the following row, it will show up as blank. So that's how basically lead and lag work by using partition by alongside with it. Now let's highlight the key entries using with first values and last values. So basically first value here retrieves the earliest row within a partition, so often based on a time or a specific matrix. So it's the same as last value, so the specific metric being the nationality. So basically it identifies the first nationality associated with the project in each discipline. Same as the last nationality, basically identify the last nationality associated with the projects in each discipline. And we've also want to ensure that it's accurate, so we use rows clause here for last value, like the basically unbounded preceding and unbounded following. Basically it's to consider all rows in the partition rather than stopping at the current one. Now let's explore relationships by using cover pop. So cover pop is basically to analyze relationships between variables. So it calculates the basically population covariance. So covariance basically measures how two variables changes together. So here it shows if more publication correlates with higher project funding within each discipline, as you can see here, non-publication total project value. So basically cover pop shows that if there's a positive value, indicates that as one variable increases, the other one tends to increase as well. So basically to show the relationship between these two variables or any variables that you've assigned to. Now, let's move on to percent rank and standard deviation. So a lot of people might get confused of standard deviation and cover pop, but it's quite straightforward because standard deviation basically calculates the standard deviation, showing how spread out the values are. So a high standard deviation indicates that it's a widely varying project value. So while a low value suggests is consistency, basically. And percent rank basically assigns a percentile base rank to each row within each partition. So this basically function here ranks universities by their project finding percentile within each discipline. It shows relative performance. So basically, it's good at percentile based analysis, like identifying top performing activities, because it divides the rank of a row by the total rows in partition, offering percentile value between 0 and 1, as you can see here. So 0.9, for example, indicates the university ranks in the top 10% for funding within its university. So basically, to recap, percentile rank basically is good for percentile based analysis. So if you want to identify the top performing activities, and standard deviation, you want to see how spread out the value is, whether it's the project values, the variables is widely varying or consistent. And cover pop basically shows the relationship between two different variables. So that's how this tree analytic function works. Now let's run it all together. As you can see, it's quite of a long queue, but let's try to run it. There you go. So now you can see these are actually a bit different because how it looks like previously, because there's only one university per discipline now. Not per discipline, for each of the discipline you can see here. So because we've used break on here, so because it's to enhance visibility of reports, so we use the break on clause. It basically groups the rows by column and adds blank lines here for better clarity. So break on groups rows by specified columns such as university and inserts blank lines between groups. This is really useful for creating polished presentation ready reports. So now that's basically our query. So in the future, maybe you guys can try to explore antiles, which divides rows into equal size groups like quartiles or deciles. Use rank or dense rank, which assigns rank with or without gaps for ties, and row numbers assigns unique row numbers, often for deduplication for sampling. So in conclusion, today we've covered several advanced SQL functions, focusing on how partition by enables group analysis, functions by like lead, lag, first value, last value, percent rank, standard deviation, and cover pop, empower comparison, strand analysis, and ranking. And also adding tools like break on, you guys can improve report readability and presentation quality. So thank you.